Before we do anything, we have to prepare the data and select the features. Features are very important in machine learning and deep learning. Features are the variables that we will use to make the prediction. So if we choose wrong features, our prediction will also not be very good. So we have to be very careful in choosing features. Our features should be not correlated, because correlation means they are same. For example, if two variables are 70% correlated, that means that they are almost same. So these are some few things that we have to be very careful. In machine learning and deep learning, what we do is we prepare examples. We give the input, and then we show the model that this was the output. Okay, means we in this course, what I will do is I will make a deep neural network that we will use to train data on gold 5 minutes, and we will use that model to make prediction about that 60 minute or 1 hour candle, right? So I repeat once again. I want to build a deep neural network. I will give that deep neural network the last 4 5 minute candles, and I'll tell that deep neural network model to tell me or tell me about that 1 hour candle, make prediction about the 1 hour candle, whether it will be bullish, if it will be bearish, what will be the size of that candle. Okay, so this is what I will do. This is a 5 minute chart of gold. So what I'll do, this candle is not closed. So I'll take these one, two, three, four candles and give it to the neural network. And I'll tell the neural network now, tell me tell me about the 1 hour candle. See, so I'll use 5 minute data to make prediction about the next 1 hour candle. Now, most of the models that people make and you'll come across on the research papers, they just calculate the return. Return is simply the close minus open over open, or it can be log return, means close of the candle with the difference between the close of the candle with the previous candle. When we make features, you see these candles, they have got wicks. This is the lower shadow. Then this is the lower shadow, upper shadow. There is a lower shadow of small, big body. So I'm not going to discard that data. So let's go and now start making the features, and then so this is a very important step that you should understand. First we import numpy, then import pandas, then this is get data. I had explained this function in the previous video also. So I have stored the gold dollar 5 minute data on my hard drive, so I'll get it, print data. Then I'll take the upper, okay, this print data. This is that print data. So once I run the code, you will see That's open, high, low, close, volume. This is the first six rows and this is the first last six rows. So there are 3,526 rows and five columns. Okay. Now we want to calculate the upper shadow, right? Upper shadow. Let me show you what an upper shadow is. See, this is the upper shadow, this is the lower shadow, and this is the body. Okay, this is the body, and there are no shadows almost. This is the body, this is the upper shadow, this is the lower shadow. This is the body, there is no upper shadow, there is a lower shadow, right? So we are going to make these features. Data upper, data high minus, data open close, maximum of open close, right? And divided by open. So this is the upper shadow. So I just named it upper shadow, would have made it big. This is upper shadow. Lower shadow is the data. This open close two columns. So we take the minimum, whichever is the minimum open and close, and then we subtract it from the low and divide it by the open. Right, and body is just the close minus open over open. Then we print the data. I'll show you. Right, so this is the upper lower body. Upper lower body. So these are, now we have made this thing. Now we shift the data. We have to take four candles. So we, upper one is the shift one. Upper means that you shift data from back to forward. Lower, shift one, body, shift one. In the same way, we take four candles. Shift two, upper two, lower two, body two, shift two, upper three, lower three, body three, shift four, right? So let me show you, explain this step also. Right? So you see these lower first four are not a number, means they are no numbers. What we have done is we have shifted this low to this place over here. This low was there, this now low 4. Right? This low was there, lower, now it's lower 4. In the same way the body, this body was there, body, now body 4. Right? So we have flattened the data. Prediction. There is an important column. Data close minus shift 12. Minus 12 means that we move the column forward instead of moving it back. Moving it forward means that now we are going to make predictions. Minus data close. So what I am doing is I am at a candle. Let me explain to you. I am here. So I move that data this. In 1 hour there are 12 5-minute candles. So this is the 1 hour candle. So I'll shift this candle to this candle column, right? And then I'll take the difference on open and close, right? This is how we make the prediction. This prediction column, now we print it. See, prediction column, this is the 1 hour candle. Next means 12 5 minute candles later, we have to predict. Now we divide the data into input and output as I had explained. So X is data, input, up body, upper, lower, body 1, upper 1, lower 1. This is that second line. Body 2, upper 2, lower 2, body 3, upper 3, lower 3, and body 4, upper 4, lower 4. This is the data for X. And then we convert into a numpy array. And then we print the first 10 rows. In the same way, prediction is just that data that predict, and then we convert to numpy array. This is all, right? This 10 rows. So I've taken, there will be 12 elements in a row. This is the numpy. Convert to a numpy. And this is the prediction. So this is how we are going to create our features. Now we have got the numpy array X, this is the input, and we have got the numpy array Y is the output. In the next video, I'll explain to you what is forward propagation. We'll build a simple neural network. First, we'll start with one hidden layer, then we'll add 2 or more layers. So we'll do that